What is going on, guys? Welcome back to another tutorial series, and in this video series I am going to show you guys how to make a packet sniffer or a network sniffer in Python. So first things first, what the heck is a packet sniffer? Well, if you were to go over to your Ethernet cable that's plugged into your router or wireless access point, whatever you want to call it, and you were to take a multimeter or somehow monitor the electricity on your Ethernet cable, you're going to notice that there are pulses of electricity. Now, we see it as just changes in electricity, but your computer sees this as ones and zeros. So whenever there's a pulse, that's a 1. Whenever there's no pulse, that's a 0. Now what your computer is going to do is eventually take these ones and zeros, convert them to binary, and eventually convert it into data, numbers, letters, images, something that's readable to humans. Alright, that's interesting, but why do we care about any of that? We usually just want to make something cool in Photoshop and send it off. We really don't care how everything works behind the scenes, unless we do, and unless you're watching this tutorial series. So one of the reasons that we may care about this is because if we ever want to make a network application in Python, such as, I don't know, maybe we want to monitor all of the traffic for our children. Well, what we can do is, as that data is being sent across the network, instead of just letting it go out our router into, internet land, we can actually look at those ones and zeros and reconstruct them. And then everyone that's on our network, we can actually see what kind of data they're looking at, what kind of requests they're making, who they're talking to, and a bunch of cool stuff. And it also helps you, let's say you were managing a big network and you had a bunch of different parts and something about your network was slow. Well, you can actually sniff all your packets and find out where the bottleneck is, where the problems are. So a packet sniffer or a network sniffer is good in a lot of instances. So that's what we're going to be doing, and also learning a crap load about networking along the way. So before we begin, let me give you guys a real quick breakdown of how we're going to code this program. Now, I assume that you guys already have the basic knowledge about networking. If you don't, go ahead and watch my networking tutorials. It's going to help you out a lot. But basically, let's say that you wanted to, I don't know, look at some dank meme off of Reddit. So what you're going to do is, on your computer, on your browser, you're going to want to request an image. You're going to want to request some meme. So you're going to take this and you're going to wrap it inside an HTTP request. So somehow you need to get this request to Reddit so it can look at it, look through its database, and send you back some dank meme. Well, in order to send it to Reddit, what you need to do is you actually need to give it the IP address of Reddit server, where you're trying to send this request, and also the return address of your computer. So whenever Reddit gets this, it knows where to send it back. However, before you can even think about talking to, some server off in internet land, you need to just get that data from your computer to your router. So basically, the HTTP request for that meme is wrapped up inside in what's called an IP packet, and that's, pretty much the address and return address for your computers, and all of that is wrapped up inside an Ethernet frame. So the Ethernet frame is the main thing that we're going to start with, and that's the information that pretty much is encapsulating everything, and that is how your computer talks to your router. So that's what we have to unpack first, so that's what I'm going to be doing in this video. So before I even make my main connections and start sniffing packets, I'm just going to build a bunch of these helper functions, and I'll say unpack Ethernet frame. And I'll show you guys this right here. This is a little demo I found online. So this is basically what an Ethernet frame is. Whenever your computer needs to send information to your router, this is what it's going to send. Now this first part, this red part, this sync, and this last one, this frame check, these aren't really important. Well, I don't want to say they're not important. They're incredibly important, but they don't have a lot of information that's useful to humans. It's really just how electronics work. This sync right here, just make sure that your computer and your router are in sync so they know when they're receiving packets. And this last one is just a frame check to make sure that it received all the data correctly without any errors. Now this blue, yellow, green, and brown one, that's the good stuff that we're looking for. So the receiver and sender, those are just who's receiving and who's sending the data, of course. One of them is going to be your computer, one of them is going to be the router. The type is just the Ethernet type or protocol, and we just want to check just to make sure that we're just working with regular internet traffic, IP version 4. So, just a standard, make sure we aren't getting anything funky. And this big brown rectangle right here, it also encapsulates the payload or the main data. So this is pretty much, if you were to think of this like a package, this was be the part, the address to and from, that's what you're writing inside, and this would be the data inside the package. So that's what we're going to be doing. So that's what an Ethernet frame consists of. Now let's go ahead and extract it. So I'm going to make a function called Ethernet frame, and we are just going to pass in data. So basically, later on, we're just going to be listening on the network, and whenever we receive a packet, just see a bunch of ones and zeros going across the network, we're going to pass it into this function, and it's going to start unpacking it, finding out what those ones and zeros are. So we already saw that, I'll say dest mac, and I'll say destination and receiver, or actually say destination and source instead of sender and receiver, since it's kind of more conventional. So source, mac, and I'll say proto. Now, again, make sure that you understand the basics of how to unpack and pack using struct. If you don't, then if you look at my Python 3 tutorials, I talk to you guys all about it. Basically, a way that you can take data and convert it to and from the bytes format. So if I go struct, I cannot type the, all right, struct dot unpack, what we're going to do is this. All right. So you know that the first argument right here is the format of it. Now, before you even write like, S or I for integer or F for float, make sure you have an explanation mark or exclamation mark. And what this signifies is that we're treating this as network data, or if you guys are familiar with big endian, little endian, it's pretty much the way that bytes are arranged on a computer. And the reason that we need to state this is because the way that data is stored on a computer is different than the way it flows across a network. Why they did this, I don't know. It should just be all the same way in my opinion, but they had to make it confusing. So basically, the way that the bytes are stored are a little bit different. So we need to make sure that this is compatible with every system. So that's why we're going to be converting it from big endian to little endian. So the destination MAC address and the source MAC address, what computer it's going to and what computer is coming from, are actually 6S, so 6 characters or 6 bytes, 6S for the source, and the proto is H, which is a small unsigned int, I believe. So after this, remember, we are only going to look at the first 14 bytes that are in that packet that we sniffed. So that's 6 and 6 for the destination and source, and 2 for the int, so 14. So how do we get those first 14 bytes? Well, that data we pass in, all we have to do is write :14, and this just means start at the beginning and get the 14 bytes that follow. So what it's going to do is we're going to pass it in some ones and zeros, it's going to unpack it, and then we're going to have the destination, the source, and the proto, which is the type. Right there. Now after this, we're just going to return that information. Now right now, all of this is in kind of a unique format. It's not in the MAC address format that you would think of in your mind. So we actually need to make another function to take this and convert it to a human readable MAC. So what we're going to do later on is I'm going to make a function called get MAC address, and this is just going to properly format a MAC address. And we're going to pass in destination MAC, and we're going to do the same thing with source MAC. I always think of mac and cheese whenever I'm say Mac for some reason. Maybe I'm just hungry. I don't know. All right. So we're going to return the destination, the source, and we're also going to go socket.htons, and proto right here. And again, this is another thing that this method right here is just going to convert to make sure that we are either big Indian or little Indian, depending on what we need to do. Basically, take your bytes and make it compatible so we can actually read it. And the last thing is just the data. 14 to the end. All right. So basically what we did in this video is we said, all right, we see some data flowing across the network and we're going to be passing it in to this function right here. So once we do, go ahead and grab the first 14 bytes and unpack it, because we know the first 14 bytes will give us the destination, the source, and also the type. So that's what we're going to do right here. And also, what we also want to return is all the data after that, because the data that comes after that, and we don't know how big it is the actual payload, the actual data. So we're going to be seeing later on. And the reason that we don't know how big this is because it differs depending on what type of data you're sending. Maybe if you're downloading an image, it's going to be big. If you're just sending a text, it's going to be small. But that's what we did. And yeah, Ethernet frame unpacked, mission accomplished. In the next video, we're going to be formatting the MAC address, and it's going to be thrilling. So I'll see you guys.